compound F. We're going to analyze this with our elemental analysis data, and we've done this before, right? So let's go with the mass of the first compound, or first element, which is 78.65, mass of the second one, 8.25, and 13.10. The atomic weight of carbon is 12.011. The atomic weight of hydrogen is 1.008, and the atomic weight of oxygen is 16. Okay? That would give us this many moles. Where's my calculator? 78.65 divided by 12.011 gives 6.548. 6.548. 8.25 divided by 1.008. My mom is in town for the weekend, and so there's a lot of background noise. Everybody's enjoying grandma. And 13.1 divided by 16. Everybody except me. I'm in here with you. 8.819. Okay? And so let's reduce these then. And we divide everything by the lowest one. So that goes to 1. And 6.548 divided by 0.81875 is equal to 7.998. 7.998. And this goes to 8.25 divided by 0.818. 75 is going to be 10, I think, right? Yep, 10, okay? So this is the empirical formula is C8H10O, okay? And so definitely it is the hydrogen deficiency index is pretty high, because if it were saturated, it would be C8H18, right? So our hydrogen deficiency index is 4. So probably have a benzene ring in there, right? Let's assume we have a benzene ring. So let's also I got my 1 out of 1 point. I got my empirical formula here. Okay, let's go on to the next color and say 8 times 12 plus 10 times 1 plus 1 times 16 equals 96 plus 26 equals 122, which is right here, okay? So that is our M plus peak, and the molecular formula equals C8H10O, okay? So our empirical formula and molecular formula, same thing. Let's go on to the next color. Oh, I got my point for that, right? Remember, I'm doing 1 point for each of these steps, okay? Got a point for that. Now let's go down. Let me scroll down a little bit and say we have to do the constitutional isomers. So let's assume that we have you know what? I don't want to just assume it. I think I have a benzene ring in there because my HDI is 4, but let's peek at the NMR. Boom. Wow. And look at that. It's got 5 hydrogens on it, okay? So look at that. We really saved ourselves some time by saying that sneak peek, right? And if it's got 5 hydrogens on it, right? That gives us, okay, let's leave it like that for now, and let me come in a different color. That means that we've 2 carbons left, right? And this is going to be too good to be true. Let me go with that little thinner marker here. Okay, and an oxygen. So it could be here, right? Or it could be here, or it could be, oh, let me go back there and do that again. It could be there, right? So what I'm going to look for now is, do I have a hydroxyl? I do have a hydroxyl, and so it's not an ether, right? It must be one of these two. Next thing I'm going to look for is still in green. Okay, next thing I'm going to look for is, do I have, because here's here's 1, 2. There's 4 kinds of hydrogens, right? Do I have 4 signals? Oh, there's a hydrogen there. Yeah, there's actually going to be 4 kinds of hydrogens no matter what I do, right? So there's another one, right? There's 4 kinds in both of these, okay? So I should have 4 signals. Let's look down here. And I do, 4 signals, okay? But it looks like I've got 2 and 2 and 1. And this has got, there's 3 hydrogens here and 1 hydrogen and 1. But there are 2 hydrogens here, 2 hydrogens here, and 1. So we know what the, even though I forgot to give here's my 1 point for my structural formula. Now let's go back to red and say that, let's go back to red and say, we're going to assume that this is the structure, okay? If that's the structure, not much of an assumption, right? Because it really fits everything I've got here so far. That's our assumption. Okay, that'll be hydrogen A. That'll be hydrogen B. That'll be hydrogen C, and that'll be hydrogen D, right? So type, number, n plus 1, and shift. Okay. So let's go here and say type A. There are 5 that are A. They have 0 neighbors. I'm treating a benzene ring like 0 neighbors. And so it's going to be a singlet, and it's going to be between 6.5 and 8. Look on page 666 for that number. Okay, B, that's methylene. It's also on page 666. Okay, page 666. That's CH2, which is right on the benzene ring. So I'm going to say that's about 2.5, right? There are 2 of those, and they've got 2 neighbors, so it's going to be a triplet. C, you see how with great discipline I'm not looking over at the spectrum now? I looked at the spectrum for clues, but now I'm just going through this structure here and going forward. You should do the same thing. That's what I'm recommending. If I could require it, I would, right? So there's 2 here, and they have 2 neighbors. So it's going to be a triplet, because this is not considered a neighbor, right? Remember, hydrogens on oxygen are just sort of lone wolves, right? So, and that is a methylene, but it's right next to an oxygen. So the closest thing we have to that is on page 663. Yep, and that's 3.7 ppm. 3.7 ppm, page 663. And then D is hydroxyl. So there's only 1 of those, and we consider it no neighbors because reasons we described in a previous conversation. We treat those like the no neighbors, and they're not a neighbor of anybody either, right? So that's going to be a singlet, and that's on an oxygen, page 666. This is between 2 and 5. And you see how I've funneled myself into the correct answers, right? So let me look for a 5, a singlet, around 7. And there it is. Wow, there's my A. Okay, now let me look for a different color. A 2, a triplet near 2.5. Boom, look at that. Gorgeous. That is my B. Okay, now let me look for a 2, which is a triplet, which is at 3.7. Wow, this is so fun, isn't it? Now let me look for a singlet. I'm sorry, a 1 that's a singlet between 2 and 5. And there it is. Okay. D, C, B, and A. And that is my structure. I'm not going to say anything about carbon 13. I'm going to pat myself in the back and say, job well done.